Okay, I'd like to welcome everyone to ISTC today and to today's seminar. For those who haven't been here before, my name's Nancy Holm. I'm the sponsored research coordinator and the seminar organizer. This is our first talk for the spring semester in our sustainability seminar series. In the past few years in our series, we've covered a variety of topics related to sustainability and climate change. And all of those seminars are available on our website, www.istc.illinois.edu, if you'd like to take a look at any of those. And we are broadcasting or attempting to broadcast live today again, so we hope to have those all up accessible on our website, and then we archive them there afterwards. This semester, we plan to have a focus on topics related to water quality, use, and conservation. The schedule for the seminars is available on the side table here, and there's also a sign-in sheet if you would. I know a number of you have signed in already, but that helps us know the attendance we have for the seminars. And then also for those who are not on the email list and would like to be, you can just leave your email address with me and we'll put you on that for future notices. So today I'm very pleased to welcome our speaker, Amy Wachenbach, who's the manager of the Watershed Management Section in the Bureau of Water at the Illinois EPA. Amy is kindly subbing for Marcia Wilhite, the planned speaker, who was not able to be here due to a conflict with another meeting today that came up unexpectedly. So thank you, Amy, for coming today. A little on Amy's background. After graduating with a Master of Science in Botany from Eastern Illinois, Amy began her career with Illinois EPA in 1987. She started in their ecotoxicology lab, a newly formed lab in the Division of Labs that looked at acute and chronic effects of effluent discharge to Illinois waterways. From there, Amy moved to the Bureau of Water, the Lakes Unit, where for many years she was a statewide coordinator of the Volunteer Lake Monitoring Program, and then ultimately Lakes Unit Manager. Amy then moved on to become the Non-Point Source Unit Manager, where she spent time implementing the 319 Non-Point Source Grant Program and other non-point source programs for Illinois EPA. Currently, she's the section manager of the Watershed Management Section that includes the non-point source unit and also the Total Maximum Daily Load Program, the Illinois Green Infrastructure Grant Program, and various other projects related to those program areas. Today, Amy will discuss water quality issues and protection in Illinois. So thank you, Amy.
Thank you. And no, I am not Marcia, and I apologize for her not being able to be here today, but right now she's getting pulled in all different directions, so hopefully I can fulfill her shoes. I'm going to give a kind of a broad brush stroke over what we do at the Bureau of Water at Illinois EPA, and try and kind of point out some of the emerging issues, some of the things that we're working on, a little background into the agency and the Bureau, and then maybe if some of these things kind of pique your interest, this might be something that you want to look at for a future seminar and really delve down into some, real specific topic. As we're going through, if you have any questions, feel free to just shout out. Just kind of keep things going and moving through what we're looking at. A real rough outline of what I want to talk about today, and it's going to seem like, I'm going into my ADD, something shiny, because I'm going to bounce around a lot. And that's because so many of these programs are interrelated that they're looking at the same things from different angles. So please bear with me. There is kind of a method there. Historically, 1972, we had the Clean Water Act passed. That basically set out the guidelines for Bureau of Water. We had the primary objective to protect and restore our nation's waters, that was our objective, with the goals of eliminating discharge of pollutants to our waters, as well as making all our waters fishable and swimmable. Those are both laudable goals. 40 years later, we're still trying to reach those goals, but we've come a long way since the late 60s, early 70s, when we had in the northeastern part of the nation rivers burning and a lot of people upset about water quality and starting to move forward. The strategies that the Clean Water Act set forth for us. Developing performance standards. This is getting those industrial effluents to start being accountable for what they're putting into our waterways. It tells the states that they must set specific water quality standards for appropriate pollutants, and that the states must do it because nationally you can't have one criteria for one pollutant for the nation. There are too many differences in types of rivers, types of streams, creeks, lakes, reservoirs, too many types of water bodies to set those national standards. Clean Water Act also provided funding for states to start increasing their infrastructure, start building wastewater treatment plants that weren't going to discharge pollutants like they were. It also provided for grant funds, which I'll talk a little bit about, so that you can get down into very small projects, not just the big infrastructure projects that most of us are familiar with. It also set forth a permitting process for wetlands and aquatic habitat. This permitting process is one that you would see run through the state agency like Illinois EPA as well as the Army Corps of Engineers. And this gets mostly at wetlands and mitigating wetland losses. So those are the things that we are trying to implement through our Bureau. Where we were, where we're at. 1972, 1/3 of our nation's rivers, streams, and lakes were fishable and swimmable. Today, we're up to about 2/3 that are fishable and swimmable. Still, we have a ways to go, but we are making progress. Wetland losses in 72, 460,000 acres annually. That's a lot of acres. But back then, the thought was, you want to put in a strip mall. You're in a low-lying area because you got it for cheap. Go in, fill it, and you've got your strip mall. Today, that's not allowed to happen. If it is allowed to happen, you've got some very strict mitigation processes that you have to go through. It could be you're putting in 2 additional acres for every acre of wetland you lose, or it could even be more stringent than that. So right now we're looking at 79 to 90,000 acres lost annually, and I would say every year that gets less and less. Agricultural runoff, we're sitting in one of the best agricultural areas in the world, and if not, in one of the best places right here in the middle of the state of the world. So obviously ag runoff is a concern, and it's also something that we can all look at and try to reduce. 2.25 billion tons of soil annually in 72. Associated with that, you have the nutrients, phosphorus, and nitrogen. Phosphorus mostly being attributed straight to the soil loss. Nitrogen less to the soil loss and more to tile outflow. Today, we've cut that loss by 1 billion at least. And then associated with that are the reductions in the fertilizers. Sewage treatment plants in 72 served 85 million people. Today, 173 million people. A huge jump there. But the most important thing with that huge jump is also the technology that we have today at wastewater treatment plants is far and above what it was in 1972. So not only are we treating much more of the waste, we're treating it much better. Quick map of what Illinois looked like in 1972 as far as assessed rivers and streams. The red is obviously bad. You see quite a bit of that in 1972. Very little of the red segments in 2010. You got a couple up here, a couple in the Chicago area, a couple down here. Those are primarily attributed to very specific land uses, or, well, land uses up in Chicagoland, obviously. That's an urban area. There's some very different issues up there, and it causes some big problems for rivers. Down in these areas, you're looking at coal mining issues or strip mining issues, basically some legacy pollutants. The other difference between the two maps, in 72, you're going to see a lot of gray. Those are unassessed rivers and streams. 2010, a lot less gray. So we're monitoring our water bodies much more, or well, we're getting to them, whereas in 72 we had not previously monitored them. Talk a little bit about those monitoring programs. Rivers and streams, we've got an ambient water quality monitoring network. This network has been in place since 1978. We have been at the same sites every 6 weeks since 1978, for the most part. And I say the most part. Prior to, I think it was 3 years ago, we had 214 sites. We had to cut those sites back to 146 because of budget and staff constraints recently. We're looking at 55 parameters at each of those sites every 6 weeks. Sometimes more if we've got some specific projects or we're looking at something special on that particular site. We've got 4 sites on the Mississippi River. 11 sites. We monitor those 4 times every year. And then of those 157 sites, we have 2 subgroups. One is pesticides and one is chlorophyll. And those sites are selected based on where they sit in the watershed. We want them to be representative of their smaller watershed so that we can look at what's going on up above those sites, both with pesticides and chlorophyll. We have an intensive basin survey, and let's see, there we go. Every 5 years, we will have some intensive monitoring going on in those kind of mustard basins. Every 5 years in the green colored, and then there's 2 more sets actually there of basins that you're not seeing. We'll go in and do at least 2 water quality samples. That's for chemical analysis. We'll also do once during the year a habitat monitoring, and then fish and macroinvertebrates. So we're getting a really good look at those sites. Those sites include the ambient sites as well as some additional sites. And so we're not just looking at chemistry, but we're looking at bugs, fish, habitat, the whole what's going on in that small watershed. Our lakes program, we have an ambient lake monitoring program. We look at about 50 lakes every year. 30 of those lakes are lakes that we visit every 3 years. We set up 3 sites generally on a lake. We visit those lakes 5 times during the year during the growing season. We're looking at water chemistry and sediment chemistry, macrophytes, phytoplankton. What are the plants doing? What are the bugs doing? And then we're also looking at the public water supply lakes, metals and organics. The Clean Lakes program, this is a very intensive monitoring program where we pick 2 to 3 lakes every year. If funding allows, right now funding isn't allowing, so I kind of will brief over this one, but it's going out to the lake and sampling monthly throughout the year, looking at trib sites. We're looking for water budget, what's coming in, what's going out. Same thing for nutrients, what's coming in, what's going out. And from those processes, we are able to develop a plan to either restore or maintain the health of that lake. And then the Volunteer Lake Monitoring Program, that program started in 1981. It's one of the oldest lake monitoring programs in the nation. We've got over 170 volunteers throughout the state. They go out twice a month from May through October, at least. Some of our Uber volunteers try and go out in the winter. They're hacking through the ice trying to get Secchi disc readings. So they're measuring transparency, how far down in the lake you can see, which gives us a real good baseline of what's going on at the lake. Gives you some trends, gives you some information on if it's sediment or algae dominated, things like that. Oops. Okay, assessed waters. We have 119 some odd thousand miles of streams in the state. We have assessed just over 17,000 miles of streams. We're not doing real good as far as percentage of streams assessed in the state. Again, that gets at staff time, very intensive. It's very staff intensive, time intensive to get folks out there monitoring streams as well as just getting to the site. We're a really big state. Lakes, on the other hand, since lakes are kind of combined, you know, they're in a big area or a small area, lots of water. We do a lot better with assessing our lake acres. We're at 58% of all lake acres assessed. And some of those lakes we will never get to because we've got a lot of private lake associations in the state. And although the water is owned by the state, the fish are owned by the state, we are not able to access those lakes. Okay, one of the emerging issues that we're working on with both the streams and the lake monitoring folks is HABs, harmful algal blooms. We've been monitoring since 2005, looking for toxic blue-green algae. You can see the red and the green are where we're seeing blue-green numbers, toxic blue-green numbers, that could potentially cause a harmful algal bloom. The blue and the green on the stream, those are where we're definitely seeing the toxic blue-greens, but probably not in high enough numbers to really cause a problem at a public water supply. And all these that have been sampled, except for the farm ponds, are all public water supplies. Public water supplies cannot easily treat for harmful algal blooms if they occur in that public water supply. That's why we're focusing on these public water supplies. And if you look, this is an algal cell. These cysts here, that's where the toxin within the blue-green algal cell lives. If that doesn't lyse, you're okay. It's when you get a bloom and all these things bust open at the same time, that's when you have your problem. So if you have an algal bloom like this, you have to be very careful in your management of it because you don't want to go out and copper sulfate or whatever you're going to use to kill off the algae, because then you have the cells lyse and you've released the toxin. We also identify, for those waters we deem impaired, the causes and the sources of impairment. For streams, these are the things we're looking at: fecal coliform, low DO, mercury. Somebody was asking about mercury. Mercury is primarily from atmospheric deposition, so it's not something that we can do through a water program easily to take care of. PCBs, primarily a legacy pollutant. Back when you had industry that was just discharging whatever they wanted into our streams, that's where you're getting those PCBs. Total phosphorus, manganese, sedimentation, and total suspended solids, those are all primarily due to soil erosion. Those are going to all kind of go in together. Inland lakes, you're going to see the same type of causes, only in a little bit different order, with the exception of aquatic algae. You're not going to see algae so much in our rivers and streams because they're flowing, and they kind of keep those algal cells broken up. You'll have algae growing in some of the slower, more lotic areas of the stream. You'll see those as well. But it does become a problem in our lakes at times. The sources, where are those pollutants coming from? That's what what the source is. Source unknown, that's our top designation. It's very difficult when you're going in, pulling grab samples, maybe doing a quick habitat assessment to be certain or say with some certainty what is going on in that watershed. But then again, there you've got your atmospheric deposition, crop production. Stream channelization can add a lot of sedimentation to your system. Municipal point sources and urban runoff. Those are your streams. Kind of the same source identification over here on the lakes. We move crop production up a little bit, and shoreline erosion, which would be kind of the same as stream channelization. And again, you've got your urban runoff. Nutrient-enriched sediments is something that you would look at only in lakes. That's the bottom of the lake where you've got a lot of unconsolidated sediments, and you're going to have a high level of phosphorus in there. When you have lake turnover, or you've got a lot of wind action or boat traffic, it's going to resuspend that those sediments, and that in itself can cause algal blooms. Another emerging issue, things that we're looking at within the agency, are nutrients, phosphorus and nitrogen. Excess nutrients, they are bad for lakes, rivers, streams. You will hear a lot about them for the Gulf of Mexico, Chesapeake Bay. It's a big issue, not just for Illinois, but for the nation. Every one of us in here is contributing to the nutrient problem. There isn't anything we do that doesn't somehow help with nutrients in our waterways. So list here is just a quick list of some of the more popular things that attribute to nutrients in our waterways, both point and non-point source. And by point, I mean it's a discharge into a river or stream by a pipe. Non-point, it's flowing over the ground and getting into our waterways. If you're interested in nutrients, we have a web page on our web page that is, it looks specifically at our nutrient problems and what we're doing within the agency to address those. Okay, I was up on the surface water. I want to go down into groundwater here real quickly. Our monitoring program for that, we've got 350 community water supply wells that we monitor on a regular basis throughout the state. We're looking for pesticides and other chemical contamination within those wells. We're looking for background information and trend information. It's very similar to the ambient monitoring network that you see for both the streams and the lakes. Yes, sir.
My name is Alan Kurtz. I'm a member of the Champaign County Board. I'm chair of the Environment and Land Use Committee. The Illinois EPA has issued a permit to the Pine County area-wide disposal unit to build a massive PCB storage center. I've been involved in that and have visited this storage facility. This facility will hold millions of gallons and pounds of PCBs coming from the Great Lakes, which will be placed directly over the Mahomet Aquifer, the only drinking water in central Illinois for more than 650,000 of our citizens. The number of jurisdictions, Champaign County, Urbana, City of Champaign, Normal, Savoy, and other jurisdictions are opposing this landfill that the U.S. EPA is about to issue a permit for. We have found the fact that PCBs, if leaking through this landfill, will pollute the Mahomet Aquifer and cause our drinking water to be unacceptable in central Illinois. Now, I've been reading this, and I was hoping that Marsha would be here today so that I could directly criticize the Illinois for being hypocritical. We're talking about protecting our drinking water. And the only drinking water we have in Central Illinois is Mahanabaki. Now, I just want it to be known in this group why I'm so concerned. And
I absolutely appreciate it.
Continue with your. This is not criticism of you personally.
I don't take it. I absolutely appreciate your concern. And if it wasn't for concern of individuals like you and other citizens, we could run amok. And there wouldn't be environmental protection agencies throughout the nation because it was citizens concerned with their drinking water, recreation, fish, that led to the Clean Water Act. So, no, I very much appreciate that concern and will take that message forward. So, anyway, 3,300 active wells that are within the state. We do only monitor 350 of those, but again, we use a statistical approach of how we select those wells. They are randomly selected, but we're looking for certain things within each one to put them in a characteristic so that we are monitoring all types of wells under all situations in the state. Yes, sir. Yes. No, it is the same throughout the monitoring, the life of the monitoring. If we have reason to believe there is something we should be doing, we will go and add a well. We do monitor wells outside this network for public water supply consumption, though, as well. So each public water supply is monitored individually. Looking at inorganic chemicals, synthetic organic pesticides, and then volatile organic compounds, which is another emerging issue. Volatile organic compounds. I like to think of these things as the stuff that smells good. Some people don't like the smell, but, you know, when I open a can of paint, I kind of like it. And for a short time. But that's kind of, okay. Let me rephrase that. I get physically ill at the smell of but these are very important in our groundwater because if they get into our groundwater, they are difficult, if not impossible, to treat through the public water supply process. And they are a carcinogen. So we are monitoring. You can see from the graph they are increasing in our groundwater monitoring throughout the state. We also monitor for VOCs on our surface waters. At each of the public water supplies, we will monitor for them. And you expect to see high quantity of VOCs in a lot of our reservoirs because the old two-stroke engines leak a lot, plus just combustion of, watercraft. So we do monitor. You don't see as high of levels there because they are extremely volatile. And so they don't stay in the system very long. Right to know is a law that tells us that we must let every consumer know if there is a VOC detected in their well. You can see here most of them are in upstate Illinois, and that's because that's where you're going to get most of your groundwater public water supplies. Downstate mid-state's a mix of ground and surface water. Downstate's is almost entirely surface water. Okay, quickly, our National Pollutant Discharge Elimination System Program, NPDES. This is the permit program whereby anybody who's discharging into a waterway must apply for a permit. For the most part, it means a pipe. You've got a pipe into your waterway. But let's talk about a couple of the different NPDES permits that you have to get. There's a state construction operating permit. If you're going to be constructing a new wastewater treatment plant or pumping stations or connections, you need a permit. If you're going to be operating those, you need a permit. if you are, if you have a new, well, I talked about the new sewer, but if you're remodeling, you have to get a new permit. And that's where we get a lot of our ability to ratchet down on dischargers. When they need to remodel, we can revisit their permit quicker than the 5-year span that is normal. If you're going to land apply the sludge that is a part of your processing, a wastewater treatment process, you need a permit. And if you have wastewater treatment that is not being discharged into a river or stream, but is being irrigated, probably into a farm field, potentially into a golf course, you also need a permit. This type of permit, though, spray irrigation of wastewater, is something we really encourage wastewater operators to look at, because that is much more environmentally friendly than a discharge of a pipe into a stream. We had a non-discharge treatment plant in the middle of the state go up recently, and I had a call from some people who it turned out I knew them very well, but they were concerned because they were land applying the waste at a field across the road from them. And they were afraid about the groundwater, and all these concerns are very valid, and we appreciate them. What got me thinking was, though, you had over here the land application of the wastewater treatment plant, their house here, and in the middle was a huge swine operation that was using manure to make compost. And what that told me was the mindset between human waste and animal waste can be very different in different parts of the state. Okay. Stormwater. We also, through our NPDES program, permit stormwater activities. If you are a municipality of a certain size, which we call an MS4, then you must get an MS4 stormwater permit. Municipal Separate Storm Sewer Systems, that's what MS4 stands for. To me it means a municipality over around 100,000 or a urban area around 100,000. Yeah, that's Champaign. Those each have their own MS4 permit. And then what that permit requires them to do is develop a stormwater program within their entity. That program has to meet 6 minimum control measures, or has to address them. Public education outreach, public involvement and participation, illicit discharge detection and elimination. Things like your downspouts, your footing drains, other types of connections to the sewer system are probably illegal. And so we put upon those communities to come up with a program to disconnect them from their storm sewer systems. Construction site runoff. Those entities are responsible for the construction activities that happen within their communities, although they have a lot of oversight by us and her, and then post-construction stormwater management for new development and redevelopment, and then I like this one, pollution prevention, good housekeeping for the municipality. What are they doing that's right? They need to put their household in order before they're telling other people what to do as well. Emerging issue is the US EPA is looking at these stormwater guidelines right now, and they are in the process of making them more stringent. Some of the things that they are considering is the use of green infrastructure, things like pavement or green alleys, rain barrels, green roofs, things like that, so that you have greater infiltration of the water so it's not leaving the site. They're looking at maybe a percentage of your stormwater plan has to include green infrastructure. Performance standards, things like post-construction sites, everything from, and this is arbitrary, but everything from 1 inch of water in a 24-hour event has to be held on the site and cannot leave the site. Area of disturbance for construction. Currently, you have to have a permit if you disturb an area of 1 acre or more. They're looking at making that smaller. And they're looking at adding monitoring as a required component of the plan or the program. Good. That'll be interesting to see how. Yeah, and that's one of the things they're looking at is monitoring the turbidity of the runoff that you do have. In PDS, CAFO permit, concentrated animal feeding operations, where you've got a large amount of animals on a site and you meet certain requirements, you are required to get a CAFO permit. This is basically some of the background information. CAFO rules were originally put in place in the 70s. Right now what we're looking at is identifying those feeding operations that have the potential for stormwater runoff to go from the feeding operation and reach the stream. So that is what constitutes the discharge. Right now, we may have as many as 500 of the large CAFOs in the state and 27 mediums. We're in the process of figuring out who's who, getting that information, reaching out to those operators, and getting them to comply within this CAFO. They have to apply for a permit, they send us an annual report, and they have to develop a nutrient management plan for their facility. This is one of the areas we've actually been able to hire a few people in at the agency. We've been able to get a couple engineers to review the reports as well as the nutrient plans, and we've been able to get a couple inspectors to go out and work with the operators to get these developed. Some other programs, talked about water quality standards, monitoring and assessment to determine the attainment of those standards, listing of waters not meeting attainment. Once we find out they're impaired, we must list them. When we list them, we're required by the Clean Water Act to develop a total maximum daily load on that pollutant. And for that, we are looking at what the pollutant is, how much is actually entering the waterway, and what that load needs to be reduced by in order to bring that water body up to full use support. Once we develop what that load reduction is, we separate that into two sections. A waste load allocation, which is an allocation that's given to our permitted facilities, and they have to then, by permit requirement, reduce their loads. And then there is a load allocation. That load allocation then goes to our non-point source side of things, which is voluntary reduction of loadings. But we try to encourage that through cost share incentives, different grant programs that are available, information, education, outreach, that type of activity. New and expanding municipal wastewater treatment plants are now required to reduce phosphorus loads. If a new one is going to be automatically required to have that lower limit, then those that are expanding are also put into that same arena. And yes?
Agricultural BMP on the load.
We've got, and it's not the best tool in the world, but there are some worksheets out there depending on the soil type, slope, the practice that you're implementing, how big that practice is. You can come up with load reductions for nitrogen, phosphorus, suspended, or not suspended, but solids. So there's some workbooks, tools out there to do that. We're working on a statewide nutrient strategy. This gets at that nitrogen and phosphorus issue I was talking about. How do we reduce those? Both our point sources as well as the non-point sources. And within the non-point, we're looking at both agricultural as well as urban non-point sources. So that's ongoing. In conjunction with that, and back up to our water quality standards, we are still working through a process of developing nitrogen and phosphorus water quality standards. Much more difficult than implementing a strategy and moving forward. While we're moving forward, we're working on those nutrient criteria, trying to get the science right for Illinois so that we're implementing something that's doable. Some of the programs that we use to help restore and protect our waters, and there are many more. I mean, I could go on for 2 hours in just the programs that we offer or that we implement to protect and restore water. So, 319 grant program. This is a competitive grant program. It's a cost share. It is for implementation of best management practices to improve water quality. You can also, through this program, do watershed-based planning, where you're going out and looking at your whole watershed and developing a plan, somewhat like the TMDL, for that watershed. You do a lot of outreach. You work with all the local entities within the watershed, stakeholders, bring them together, come up with a plan. We've also got information and outreach grants that can be had, and then monitoring activities as well. Focusing on waters impacted by non-point source pollution. That's lakes, rivers, streams, wetlands, all Illinois waters. The Illinois Green Infrastructure Grant Program, it's again, another matching program. This one, whereas this program here, the 319, is for non-permitted activities. Green infrastructure could be something that's a permitted activity. If someone with a stormwater permit wants to do something to help meet their permit requirements, they can come to the Green Infrastructure Grant Program and be eligible. But it's looking very specifically at stormwater, and it's also looking at MS4 communities or combined sewer overflow communities exclusively. So if you don't fit into one of those, you wouldn't be eligible. Yes? Green infrastructure is, there's 2 different cost shares. There's a couple different program categories within it. One is aimed at combined sewer overflows. We're looking at those as causing the biggest impairment to water quality. That cost share is an 85% state share, 15% recipient. The other 2, which is a small grant program and a infiltration retention category, those are 25-75. So 75 to us, 25 to the recipient. The Illinois Clean Lakes Program, that's a program that would follow the Clean Lakes monitoring that I talked about, the 12 months intensive monitoring, doing a diagnostic, figuring out what the problems are of the lake, feasibility study, which is very similar to a watershed plan. What are the problems and how do you want to fix it? Those are all one piece. And then there's an implementation portion of that program. Again, that particular program right now is not funded, but we're hopeful that in the future it will be. It looks specifically at inland lakes and reservoirs. Wastewater state revolving funds. Our SRF program is a loan program for infrastructure, sewers, building wastewater treatment plants, lift station, pump stations, all that kind of moving wastewater from your house to someplace else. It is a low interest loan. You pay it back over, I want to say 40 years, but it might be 30. A long time. Aimed at reducing point source pollution. Through that program, you can get wastewater treatment plants to adopt better technologies. Therefore, you've got the cleaner effluent. KIC 2025, it's not really an Illinois EPA program, but we like to take credit for it just because we do that kind of thing. The Council of Best Management Practices developed this program. KIC stands for Keep It for the Crop 2025, and basically it's the corn and soybean industry working with fertilizer companies, fertilizer dealers, as well as just ag producers, operators, to either reduce the amount of nutrients they put on their lands or to use the right kind, at the right rate, at the right time, and in the right place. So in other words, thinking through that whole process of fertilizing your land. And what they want to get at more than anything, and this is how it really sells to the fertilizer dealers, because you think fertilizer dealers don't want farmers to not buy as much, but not necessarily reducing what you're putting on, but putting it on at the right time so that you are maximizing the benefit of it. So this is a poster they've put out. We've got some priority watersheds where they're really focusing some intensive efforts in those watersheds, trying to get the producers and the fertilizer dealers working together. And we're hoping to get some monitoring to see how successful that program's been. If anybody's interested in more information, if you Google KIC 2025, you come up with it right away. And with that, just to quickly go over some of our hot topics. Nutrients, huge. That's probably the biggest topic or hot topic we've got in the agency or in the Bureau right now. VOCs, water quality standards, CAFOs, TMDLs, performance standards. We are working to develop some of our own performance standards within the agency for construction sites and post-construction. And then shrinking staff and lower funding levels. You guys don't want to hear about it. Everybody knows it, but it's definitely a hot topic within all of government and businesses, really. So with that, questions? Yes?
Within the TMDL program has been around for quite a while, so what percent of the water bodies that have had TMDL have now met their TMDL, have met their...
See, you're supposed to ask me questions that aren't really my arena, so I can say I don't know, but I'll get back to you. But since I oversee the TMDL program, I should know that answer. I can tell you it's, and this is where we do TMDLs on causes for which we have, or typically for causes which we have a numeric water quality standard. So we have a known endpoint. So by getting that cause off the list, we still have the water body potentially on the list for something else. So it's real hard to tease out what that number is, but I'm going to tell you it's not near what we'd like it to be. It's probably not, and that's because all our nutrient TMDLs are on lakes, or 99% of them. We got a few nitrate TMDLs, but the majority of them are on lakes for phosphorus, because we do have a nutrient standard for phosphorus on lakes. And it doesn't take a rocket scientist to know if you put a dam in the watershed and you've got too much phosphorus down at the bottom, it's not going to go anywhere. And it's even if you stop the loadings to the lake, it's still there. And so we really don't expect those to be restored up to at least the levels of phosphorus that we'd like to see. We are required by the Clean Water Act to do that. Yes. Yes?
What's the source of the VOCs in groundwater?
It's those sources that the paints, the combustibles, the fuels, it's leaching into the groundwater. It's not a source that's under the ground already. It's stuff we're doing up here.
In this area, one of the problems is when we had gas meters. Or the old gas stations where we
Yeah, leaking up. Well, in that case, it would be underground, but leaking underground. Mm-hmm. Anything else? Yes.
Yeah, you mentioned the cable right now. EPA also focus on mostly initiative like stormwater runoff. But I just wondering, do you think about for the kind of this animal wastewater for land application?
Yes, there is a lot of land application that goes on for any of the animal facilities. One of the issues that we do have with that is land applying on frozen ground, and that's something that we expect them to address in their nutrient management plan as not being acceptable. We don't accept that as a good business practice. But otherwise, yes, given the amount of land that's out there and reducing commercial fertilizers, that's a good way to go. Thank you.